When a coffee bean reaches temperature and cracks inside a roaster, it rapidly expels over 800 distinct volatile aromatic compounds into the air. We rely almost entirely on the human palate to evaluate this massive chemical dataset, yet the resulting scores dictate the hard, objective financial architecture of the global coffee trade. To manage this contradiction, the industry uses a strict 100-point metric known as the Q-score. For a coffee to achieve specialty grade, it must score at least 80 points and possess 0 Category 1 primary physical defects. Consider a coffee that lands at exactly 85 points. Human sensory perception naturally drifts with age, diet, and biology. We have to ask how a highly variable biological instrument can reliably generate a fixed, reproducible number like 85. That number acts as the mathematical survivor of a standardized physical, chemical, and sensory gauntlet. To evaluate the bean accurately, evaluators must first stock away all environmental variability in a controlled testing lab. The physical controls start at the roaster. A sample roast must be completed between 8 and 12 minutes, and the freshly roasted beans must be immediately air-cooled. Quenching them with water is strictly prohibited. The batch must meet an exact color metric, a 63.0 on the Agtron-Orme scale. This prevents a heavy roast profile from masking the coffee's origin characteristics. Moving to the brewing phase, the sterile machinery used to prepare the sample is completely locked down. The brewing water chemistry is tightly constrained. Total dissolved solids must measure between 125 and 175 parts per million, heated between 93 and 96 degrees Celsius. This high-contrast blueprint shows the Golden Cup standard. It requires exactly 8.25 grams of coffee for every 150 milliliters of water. Forcing every coffee globally into these exact thermal, chemical, and physical constraints guarantees that any difference detected in the cup is solely the result of the coffee bean itself. With the variables controlled, the identical white bowls are set, and human evaluation begins. Evaluators use the Specialty Coffee Association cupping form, plotting attributes on a 16-point scale using strict quarter-point increments. The first 3 to 5 minutes assess dry and wet aroma. This phase culminates in the physical breaking of the crust, releasing the trapped gases. As you can see in this graphic, the evaluation maps directly to a thermal timeline, dropping from 200 degrees Fahrenheit. Scoring does not happen all at once. Specific attributes snap into place at precise temperature thresholds. When the brew hits 160 degrees, evaluators score flavor and aftertaste. At this specific temperature, retronasal vapors reach their maximum physiological intensity. As the liquid cools down to 140 degrees, the heat stops masking the structural components of the brew, allowing acidity, body, and balance to be accurately measured. Finally, as the liquid drops below 100 degrees, sweetness, uniformity, and clean cup are evaluated near room temperature. By tracking the coffee across this thermal decay, an 85-point score proves that the coffee maintains its structural integrity at every physiological phase of consumption. All of these strict protocols rely on the human palate. If that palate drifts, the data is useless. To solve this, the Coffee Quality Institute requires certified Q graders to undergo a grueling recalibration exam every 36 months. This scatterplot visualizes the calibration process. Graders evaluate 18 separate samples. A central algorithmic line represents the global standard, while the individual data points show the graders attempting to align with it. To ensure a well-rounded palate, the samples are divided into 3 distinct processing variables: washed, Africa, Asia, and naturals. The calibration exam matrix plots the individual cupper scores against the group mean. It calculates their exact distance from the global standard. Graders must fall tightly within the acceptable deviation margin to maintain their certification. An 85-point score is reliable because the human instrument generating it is mathematically audited for statistical drift. Before any coffee reaches the cupping table, it has to survive an initial physical audit. Graders pull a highly specific baseline volume for evaluation, exactly 350 grams of raw green coffee beans. Looking at this grid, we see the system of defect math. 5 distinct broken beans merge mathematically to equal 1 full defect. Single minor defects are combined based on their estimated impact on the final cup. Decimals are not permitted. The calculation is always rounded down to the nearest whole integer. To pass into specialty grade, A lot must contain 0 Category 1 primary defects and a maximum of 5 Category 2 secondary defects. Failing this physical math immediately disqualifies the lot. Therefore, an 85-point score represents near-perfect physical farming practices, well before flavor is ever considered. Once certified, that 85-point score dictates the financial value of the producer's entire crop. At this crucial post-roast stage, the single greatest invisible threat to the coffee's ultimate value is atmospheric oxygen. Oxygen exposure actively degrades the 800-plus volatile aromatic compounds that the Q grader just verified. Roasters protect this investment through hermetic packaging systems. This cross-section shows the physics of a one-way degassing valve. The design allows carbon dioxide buildup from the roasting process to safely push out of the bag. Simultaneously, a tightly closing mechanical diaphragm locks into place. This instantly blocks external oxygen from re-entering the package. This mechanical barrier physically traps the specific aromatics evaluated back at the 200-degree crust break. The 85-point label serves as an objective technical certification. Sensory analysis in specialty coffee functions as a mathematically verified chain of custody, a scientific system designed to protect quality from the soil to the final cup.